Good morning, everybody. Time to wake up. We're having a great public forum. Please come and join us. Seats are available. Drinks is on the house. Time for a nice coffee. My name is Marie-Hélène Nieb, and I have the opportunity to welcome you to the group exhibit, Hydrogen Fuel Cell and Batteries. We shall discuss speeding up commercial breakthrough, SOFC, SOEC, know-how from DTU. Please help me welcome the head of section FCH Test Center from DTU Energy, Professor Dr. Anke Hagen. Thank you for joining us. I'd like to start this interview by, if you could give us a perspective of the political settings for new energies in Denmark.
Yes, I really like to start with that also, because I think there is a quite unique situation in Denmark. Denmark has an ambitious political goal. Politicians have set energy strategy, and they aim to be independent on fossil fuels by the year of 2050, which is quite soon. So to be independent on natural gas, oil, etc. And the idea is to base all the energy production on renewable resources such as wind, solar and biomass. And in particular, maybe you know that Denmark is very strong in wind energy, and we are in a really good way to establish more and more capacity to produce electricity from wind. We are approaching the 50% and are quite in the plan, which is quite a nice situation. But as you all know, on the other hand, fluctuating electricity input gives some challenges. Already now we have situations where there's excess wind electricity, which is not needed by the customer. And on the other hand, we have situations where there's no wind and there's need for electricity. And in the future, if you don't have the large power stations to balance the situation, you need some other technologies that can produce electricity when it's needed or store electricity when the wind is blowing too much. You all know that also Denmark has no nuclear power, so really the option is renewable energy sources and new technologies. And among those are solid oxide fuel cells and solid oxide electrolysis cells. And these two technologies are really considered key stones in the puzzle for a next future energy scenario. And that has also led to the situation that there is a good political support on newer technologies, among those SOFC, SOEC, also other batteries or PEM fuel cells. And that has also led that we have really focused a lot in the past years on developing these technologies. Also with generous funding from Danish side, national side, of course also international funding in European projects, for example.
So they made Denmark has decided to really put their foot down, make a big announcement. By 2050, we will be totally independent of renewable energy, renewable only. Yes. And it kind of puts a lot of pressure on DTU Energy in some ways. You have to bring up the technology and you have little time. Like you said, you're getting good support from the Danish government in terms of funding, but it's not like they just started to fund you. They've been really good all along, and that's why you have so much experience at DTU.
Yes. I also have to say that the pressure is only on the utilities, which now have to handle the situation with it's not only the research, but of course it gives us good opportunities to develop the technology. And as you mentioned, already in the 80s we started with research on SOFC, and we went together with a company, a Danish company, which in the past 20 years expanded quite a lot together with us. And we had a lot of mutual projects and came quite a long way on the technology development. And in that process, we built up a lot of know-how. We are at our institute or department at the moment, maybe 30, 40 people or headcount. So it's close to 80 people that work with SOFC, SOEC. So this is quite a substantial effort. As a research unit, I also want to stress that we span a whole range of levels. So we start, of course, with fundamental research, looking on the fundamental processes, nanoscale, microstructures, but we also have the ambition to help the technology to come to the market. That's our interest, of course. And we, in parallel that the technology has developed, we also developed to larger levels, so to speak. So we produced cells, fuel cells ourselves. We scaled up production with scalable methods like tape casting, screen printing, and so forth. So we are able now to produce thousands of cells. And we also followed all the other developments through stacks, even to systems, because we really want to help this technology to succeed. If it does so, then all the money and our research effort was successful, and we will also in the future have opportunities to develop the next generation technologies, next generation cells, materials as a university, of course.
So like you mentioned, you have quite a large team that works on FCH technology. And can you give us a list of all the different sub-areas that the expertise they have? Because it's a large field, there's sub-fields. Can you give us more details on the areas of expertise they have?
Yes, our organization is such, so our department is maybe 250 persons, and we are organized in a way that we have competence areas that include, for example, electrochemistry. So we educate and develop electrochemists on the highest possible level. We also acquire equipment that is needed for that. When I talk about electrochemistry, I mean both fundamental questions, developing new electrodes and test them, but also to test cells and stacks. And what we do in that area is we develop methodology, so we are able to test a given cell in the best possible way for performance, assign resistances or performances to specific components in the cell, so to be able to give a good feedback to the developers where the cell is working well or where they need to do improvements. And we try to do it really on a very detailed level, like giving feedback such as you have to make one electrode more porous or less porous. So on that level. So this includes electrochemistry. Other fields of competences are microscopy. We work quite intensively and have a lot of microscopes on different scales, electron microscopes, optical microscopes. We try to develop methods and have done also successfully to characterize fuel cells in a most proper way, so to get the best information out of it. Now, I don't want to talk science, but those of you who have seen a microscope picture, it's sometimes really difficult to see anything on it or deduce anything. And we have developed methods to make the real, those properties visible that are needed or that determine how a cell is working or not. This is a field microscopy. Another field of expertise is mechanical testing. Those who work with ceramic fuel cells know probably that mechanical properties are enormously important. So we need to address them, test them, also in the best way. Some unique feature we have that we can test those cells at the elevated temperatures. That means 800 degrees centigrade and in the right atmosphere, in reducing atmosphere. So we get a mechanical property under the correct conditions. And these values might be much different from conventional mechanical testing at room temperature. But that is, of course, what plays the main role when you later on use the cell. I could add more competences. One is, for example, processing, ceramic processing. I mentioned that we can produce thousands of cells. We also develop methods that are scalable. So our ambition is, of course, to make the world's best cell, but we also think about what when we need this cell in several thousand pieces, then we need to upscale and have methods that can be used in that scale. And I mentioned already we rely on tape casting. We make multi-layer tape casting and screen printing and so forth. So we already, when we do the research, we have in mind that we need to scale up at one point. And maybe I can stress that we think our strength or belief that is we can combine all these competences. So that means we have one microscope expert, like one of our exhibitors, Carl, is expert in microscopy, and he applies his knowledge to the fuel cell, where an electrochemist has tested it and said, okay, I think the interface electrolyte anode, there is something wrong or there's a challenge, can you look at this? And then we go to processing and say, you know, we believe the cell would work better if you make it more porous. Then processing can react in a way to put more pore former in a slurry or respond in a way. So I think our unique strength is that we combine all these forces to solid oxide fuel cell technology or electrolysis technology or batteries and so forth. But now, today, the focus is on SOFC, SOEC, of course. So we have a lot of experts in different fields, which are maybe traditionally would be quite separate in different institutes or groups. But we tried to combine, and we succeeded so far quite a lot, I think, to combine all these competences to develop a good or help to develop a good technology.
So that brings me to a question, but before I do so, I just want to remind everybody this is a public forum, so you're more than welcome to ask questions. I'll just come down, raise your hand, and I'll bring the microphone. But you mentioned earlier about how much effort DTU is putting towards applying the technology in some ways, not just doing, I'd say, fundamental research. And that brings me to one of the big Danish company that closed out last year, which is very sad news. And you were working very closely with them. What effect this has on DTU? Are you losing a lot by this closure?
Yeah, so I have to repeat that last summer, the company Topsy Fuel Cell closed. And that was quite a big company with big effort in SOFC technology. And we had already from the start partnered a lot with industry, in particular with this company. So that was, of course, very sad news for Denmark, because one of a potential developer and of the technology was no longer working on that area. I also want to stress they now put all the resources on developing solid oxide electrolysis cells, which are more or less the same cell, but in the reverse direction, so they are not completely lost as a company. That makes us happy, and we still collaborate, in particular in this area, with now it's the mother company, Halder Topsøe. Of course, it has consequences when such a big company closes. We had the fortunate situation that we were not so much affected because we work together with many other partners in projects. Here I can, for example, mention the Innefield project, where we are work package leaders. And this is maybe one example for a good partnership on a European level, which includes both PEM cells and SOFCs. This is one argument why we were not so much affected. So we have other partners, other projects, and we've been since then, and also before, in fact, very active that we offer our knowledge to not only one company, but to more companies. A few years ago, we made this test center where Eva is also here for contacts, this fuel cell and hydrogen technologies test center, where we already a few years ago thought we could speed up the market introduction of the technology when we make our knowledge available for industry. We have done so. We have tested for several companies, among others Plancy, Sandvik, Cirel. So we have already some more companies involved or partners, both on commercial level but also in public funded projects that made us not so vulnerable for this closure. We also work a lot on electrolysis, and maybe in a Danish context, we see a big potential in the SOEC because it can make a co-electrolysis. I don't want to be too technical, but it can make a synthesis gas as a product which can be converted directly by known catalytic processes to methane or to liquid fuels, which is attractive for Denmark, which has a very tight natural gas network and large storage capacities for natural gas. So natural gas or methane plays also in the future, will play a big role, or it is planned, in the form of artificial natural gas, which can be produced via electrolysis or through a biogas cleaning, upgrading, which can be put into the network. So yes, it is a very sad story. It gives, on the other hand, new opportunities to look around. And we, even the company closed, we still believe the technology is not wrong. It is very, has good perspectives. That we say it has a very high electrical efficiency is still valid, is still true. And now we just need also for, in the Danish context, to fulfill this goal for energy 2050 to be independent on fossil fuels. Now we really need to speed up the technology. Now we don't have a Danish business player any longer, so we need to attract other partners or other companies. That might also be a good opportunity for other companies, because we see a good potential market in Denmark. And as I mentioned, we do all to support this, because we don't want to have just one industry to succeed. We really, at the end, want that the technology succeeds. So we can say that was a successful story, and we can, in the future, also deliver the next generation cells, the cheaper cells, the better cells, and stacks, and so forth.
A few minutes ago, you mentioned any field. What will be DTU involvement in that project, in more specifics?
Yeah, I can, of course, refer to the expert, Eva. She's sitting here for more questions, but we are involved in the surveys, analysis, data collecting, redistribution, and so forth. And I mentioned this as a very positive example because it combines in one project also competitors in the field, but I think everybody has recognized that we only can succeed together. There are other examples in other countries, like in Japan, where a commercial product is available, which is also the result of more or less partnering of competitors with a common goal to make a commercial product. And I think that is also needed now in the light that, like Topsoe Fuel Cell, also other companies have stopped their activities in the past and new emerged. So it's a very moving market, but I think the story is we cannot succeed alone on our own, so we should partner and should learn from other success stories like from Japan and try it in a similar way. But remember that we have this common goal that we want the technology to succeed, and there will be place for many players, of course. I think so.
Yeah, and I think Denmark will really set the benchmark with their goal of 2050, not relying on any fossil fuel. I think more than anything, hydrogen and fuel cell will have a place in that market. You don't have a choice. I think that's the only way you'll get there. But I also want to mention the DTO offers, which is maybe not as known, like you're known for your research, your help towards bringing a certain technology faster to the market, but you also offer education courses.
Yes, a part of our test center concept is to offer education. Of course, students, we do a lot at university, but we believe that if you want to install a unit at a house, you need also technical personnel, and we make tailored courses for those professionals to become an expert as it's needed on the level that is needed on SOFC to be able to install the units, to troubleshoot, and to do the maintenance. So that is one offer we also have from the test center, which is maybe more potent in the future and more needed in the future, but it could be a good idea to start at the early stage with a smaller group, and in particular Enefield has some players who install quite a lot of units in the market.
I think it may help also public acceptance. When there's more and more people knowing about it, it might bring it. So I think it's a an important aspect of what DTU offers. Unfortunately, we're running out of time, so if you have any more questions for Dr. Hagen, I invite you to visit their booth, which is located on the left-hand side here, or your right, at E65/2. I want to thank you for your time, and thank you, Dr. Anke, for your time. Thank you.
Nice.
And stay with us, we have more. We'll be discussing with Serpotec advanced ceramic powders for the next generation of energy materials in a few seconds.